For this video, we are going to review a couple problems having to do with writing equations given some information about a polynomial, and then get into using long division so that we can come up with exact imaginary roots and also irrational roots. So in this first problem here, it says that we're given the function that's a quartic function, quartic meaning that it's a fourth degree polynomial. So this means that it's an x to the fourth. And a limited table of values is provided. Write the equation of the quartic polynomial in standard form. So one thing that we should know about a quartic polynomial, since it's a degree 4, is that it should have 4 roots, okay, or 4 zeros. So we should see 4 x values that we get 0 back for our function. If we do see those, we have them all. If we do see 4, then we have them all in the table, and then that's good. Then we just need one other point to help us write the overall polynomial. So we're going to go ahead here and start writing out this polynomial. So we don't know the a value or the constant, okay, but we can take all of these zeros. So remember, if we know that x equals -4 is a 0, if we bring this back over to the other side, that means x plus 4 was one of our factors. So x plus 4 here. We have x is -3, so x plus 3 is going to be a factor. We have -1 for x, so x plus 1 is going to be a factor. And we have x equals 1, so x minus 1 is going to be a factor. So we have all of those, and then we're going to have to do, we're going to have to figure out this a value. Now, I would do the a value right now before you multiply this out because it's going to be easier. I would also choose the y-intercept if at all possible. Okay, so the y-intercept is when x equals 0. That just makes your calculations easier because you're plugging in 0 for the x every time. So what this y-intercept says is that we have, the x is 0 and the y is -12. Another way to say y is f of x. So f of x right here is -12, so we're going to plug that in. And then everywhere we see x, we're going to plug in 0. So I'm just going to write down the rest of this, and then I'll plug in all the zeros. So x is 0 in this whole thing. So then we're going to plug in 0. So we're going to do 0 plus 4, 0 plus 3, 0 plus 1, 0 times -1 to solve for a. So we have -12 equals a times 0 plus 4 is 4. 0 plus 3 is 3, 0 plus 1 is 1, and 0 minus 1 is -1. So now we just have to multiply all of these together. So 4 times 3 is 12, times 1 is 12, times -1 is -12, and then we still have that a. So then just divide both sides by -12 to find out here that our a value is simply 1. Okay, so then that will replace in here. We'll just get a 1. And then now what we want to do is write this in standard form. So we're actually going to have to multiply all of these out. So I'm just going to get some more space down here. So what we have is that this polynomial is 1. So I'm not going to write it because multiplication doesn't matter if you put the 1 down. So we've got x plus 4, x plus 3, x plus 1, and x minus 1. So now what I would do is multiply your two binomials together first. So I'm going to multiply these two together first, and then I'm going to multiply these two together. Then I'm going to multiply that product together. So you can do this in the box method if you want to. Otherwise, it's FOIL is x times x is x squared. Then you're going to get a 3x here, and you're going to get a 4x here. Add those together, and you get 7x. Then 4 times 3 is 12, so that's that first part. Then we'll multiply these last two together, so we get x times x, which is x squared, x times -1, which is -1x, 1 times x, which is +1x. Add those together and you get 0. Then 1 times -1 is -1. So I like to do those in my head and just FOIL to add together those like terms. Now, once I get to trinomial times a binomial, I do really like the box for that. because it keeps your terms organized. So then we can put the binomial, so x squared minus 1 on one side, x squared, 7x, and 12 on the other to multiply those. So x squared times x squared is x to the fourth. X squared times 7x is 7x to the third. X squared times 12 is 12x squared. X squared times negative 1 is negative x squared. Negative 1 times 7x is negative 7x, and negative 1 times 12 is negative 12. So once we combine all of these like terms, then we're going to have our polynomial in standard form. So we just have x to the fourth plus, now we only have this 1x cubed term here, so just plus 7x cubed. For the x squareds, we have 12x squared and negative x squared, so we'll combine those to get positive 11x squared. Then we only have the 1x term, so that negative 7x, so we'll write minus 7x, and then our constant negative 12. So then this would be the standard form of that polynomial. And then one thing I like to do is actually graph this. And so I'll just compare it to the factored form that we wrote. So we had x plus 4, I think, x plus 3, x plus 1, and x minus 1. So I'll actually just graph this and this on the same graph in Desmos and see that the graph overlaps itself exactly, just to make sure that I didn't make any algebra mistakes. So another way that problems like this can be written is like this. So a quadratic, okay, so quadratic just means an x squared polynomial, meaning it's going to have two roots in standard form with an a value equal to 1. So they're telling us the a value already, which means we don't have to solve for it, which is nice. And then it has these roots, okay? So I'm actually just going to write out these two roots so you can see them. So you have negative 3 plus 10i, and you have negative 3 minus 10i. So now remember, when these are the zeros, okay, the factor, so if the 0 is x equals k, then the factor is x minus k, because you're going to bring it over to the other side. So we're actually going to have to subtract these over to the x, okay, or do the opposite of them. So this first factor here is going to be x plus 3 minus 10i. Okay, so we're going to bring it over. And then this second factor here is going to be x plus 3 and then plus 10i. And then this is your polynomial in factored form. So now we're going to multiply this out. So I would do this in the box, again, because it's that's basically a trinomial times a trinomial. So there's going to be a lot of terms to keep track of here. So the box is very helpful for that organization. So we have x, 3, negative 10i, x, 3, and positive 10i. So let's start multiplying in. So we get x times x is x squared, x times 3 is 3x, x times negative 10i. So I write the real part, negative 10, the imaginary part, and then the variable. So always write it in that order. And then 3 times x, 3 times 3, 3 times negative 10i, so negative 30i. X times 10i, so again, the real part, the imaginary part, and the variable. 10i times 3, and then negative 10i times 10i. So that's going to be negative 100i squared. Okay, so now this is going to be important to remember from Algebra 2, is that I is a negative 1. So this is really, or is the square root of negative 1, sorry. Okay, so I is the square root of negative 1. And so what we really have here is the square root of negative 1 squared. Well, when we square this, the square root and the squared cancel, so I squared is just negative 1. So what we really have in this box here is negative 100 times negative 1, because I squared is negative 1. Negative 100 times negative 1 is positive 100. So that's actually positive 100. So now we'll go ahead and pull out our like terms, combine them, and get our standard form of this polynomial. So we have this x squared term. Okay, we've got now this x, it's just the 3x and the 3x that are like terms. So that's 6x, okay, because they have to have the same real, imaginary, and variable parts. So this 10ix, so negative 10ix and 10ix, they both have an I and an x part. So these are like terms, 10ix and negative 10ix, which is 0. Okay, and then we also see negative 30i and positive 30i. Those are 0 as well. And then our constants, 9 and positive 100. So we get plus 109 here, and that will be our final standard form multiplied out. One more of these. So a function is cubic, okay? So meaning x cubed, meaning 3 solutions or 3 zeros. The zeros of the function, they list all 3 of them, negative 5, 3, and 6. And then they give us the y-intercept. So remember when they tell you the y-intercept, that means x is 0, y is 360. So that's going to help us find our a value since they didn't give us our a value in this one. Okay, so we'll say f of x equals a times, get your factors from the zeros. So remember, if the 0 is x equals k, then the factor is x minus k. You have to bring that k over to the other side. So it's always going to be the opposite of these. So we have negative 5 as a 0, so x plus 5 is a factor. 3 is a 0, so x minus 3 is a factor. 6 is a 0, so x minus 6 is a factor. Solve for this a value using the y-intercept before you start multiplying out. Okay, so remember you have the x is 0 and the y or the f of x is 360. So plug that in. So we get 360 equals a times, and then you're going to plug 0 in for all the x's. Okay, so 0 for each of these x's. So you get 360 equals a times 5 times negative 3 times negative 6. So go ahead and simplify that. So 360 equals a. 5 times negative 3 is negative 15. Times negative 6 is positive 90. Solve for a by dividing by 90. And you get a equals 4. So then that'll plug right back into this function, and then we just need to multiply out to get it in standard form. So now we have 4 times x plus 5, x minus 3, x minus 6. You can start wherever you want multiplying. I would leave the 4 to the end, but you can because it'll make your multiplying your binomials a little bit easier. So you can multiply these first 2 together if you'd like. Again, I'm going to do kind of FOIL method more so in my head. So x times x is x squared. X times negative 3 is that negative 3x. And 5 times x is the 5x. Combining those together gives me a positive 2x middle term. And then 5 times negative 3 is negative 15. And then you still have this x minus 6. So now you'll want to multiply these 2 together. Again, this is where I start to use the box when you get to more than just 2 binomials. So we have x and negative 6. We have x squared, 2x, and negative 15. So x times x is x cubed. X times 2x is 2x squared. Negative 15x, negative 6x squared, negative 12x, and positive 90. So then pull those out and combine like terms. Don't lose your 4 here. So we have the x cubed, we have negative 4x squared, we have negative 27x, and plus 90. So then you just need to multiply that 4 in. So 4x cubed minus 16x squared minus 108x plus 360. All right, then we are going to get into doing long division now. So long division, so you're going to write what's being divided, okay, underneath this bar. So 6x cubed plus 25x squared plus 18x plus 14 is going to be divided by 2x plus 7. So just like long division with numbers, so we're going to take a look at this first number here and see what we need to multiply it by to equal this first term. So 2 times what gives me 6? Well, 2 times 3. X times what gives me x cubed? So x times x squared. So that's how you figure out that first number. Now you're going to take and multiply it times this binomial and write down what you get. So you're going to do 3x squared times 2x, which is 6x cubed. And you're going to do 3x squared times 7. So that's 21x squared. And then line them up with their like terms. So I put the x cubed under the x cubed, the x squared under the x squared. Then this is critical. You need to subtract. Okay, so you need to subtract these. So make sure that you do that. So 6x cubed minus 6x cubed is 0. 25x squared minus 21x squared is 4x squared. Then you carry down your next term and you start over. So now we're going to figure out what times 2x gives me 4x squared. So 2 times what gives me 4? Well, that's a positive 2. What times x gives me x squared? That's x. Then you're going to take and multiply this by both of these terms. Okay, so we're going to do 2x times 2x, which is 4x squared. Then 2x times 7 gives you 14x. Then you need to make sure that you subtract here. So 4x squared minus 4x squared is 0. This should always be 0 if you're doing it right. 18x minus 14x is 4x. Then carry down that last term, which is positive 14, and do it one final time. So figure out what times 2x gives me 4x. So positive 2 gives me the 4, and then I already have the x, so just a 2. So 2 times 2x is 4x. 2 times 7 is 14. And then again, you're going to subtract here. 4x minus 4x is 0. 14 minus 14 is 0, so you have no remainder. So when you divide this polynomial by 2x plus 7, you get 3x squared plus 2x plus 2. So that would be your answer. So what's the result? This. That also means that this factors to 2x plus 7 times 3x squared plus 2x plus 2. But if they just want the result of the division, it's just that polynomial. Okay, so let's do another one. So let's do 6x cubed minus 13x squared minus 15x plus 21. And we'll divide it by 3x minus 2. So what times 3x gives me 6x cubed? So 2x squared. Because 2 times 3 is 6. X squared times x is x cubed. Make sure you also multiply it by the negative 2. So 2x squared times negative 2 is negative 4x squared. Okay, then be sure that you subtract here. So 6x cubed minus 6x cubed is 0, and then this is where people often make a mistake. So you're doing negative 13x squared minus negative 4x squared. So I'm just going to write that off to the side here. You're doing negative 13x squared minus negative 4x squared. So this will turn into plus. So then negative 13x squared minus negative 4 is positive 9x squared. Carry down the negative 15x and then start over. So what times 3x will give you 9x squared? So positive 3x, because 3 times 3 is the 9. X times x is the x squared. Make sure you also multiply 3x times the negative 2. And then be sure that you subtract. So 9x squared minus 9x squared is 0. Negative 15x minus negative 6. So that turns to plus 6. Okay, so negative 15x plus 6x is 9x. And then carry down your final term of plus 21. And then do your last one. So what times 3x gives you 9x? So 3. 3 times 3x is 9x. 3 times negative 2 is negative 6. And then you'll subtract. So you get 0. 21 minus negative 6 is 27, and we have no more terms left. So this is called our remainder. And this problem asked us to write the remainder, okay, in a specific form. So what we're going to do is we're going to take that remainder and we're going to put plus the remainder over the divisor, okay? So what you divided by. So the 3x minus 2. Okay, so this came from right here. So this goes on the bottom. Okay, and the remainder goes on the top. All right, then let's look at how this is going to look on a graph. So when we look at this function here, we see that it's a cubic function, okay, which means it should have 3 solutions, and ours doesn't show 3 real solutions. It only shows 1. So I don't see any more times that it crosses the x-axis, which means that we're going to have imaginary solutions here. So what you're going to do is determine what your real solution is, okay? In this case, x equals 2. And you're going to divide that into your polynomial. Okay, you're going to divide that factor into this polynomial. Okay, remember that if the 0 is 2, then the factor is x minus 2. So what times x gives me 2x squared, or cubed? So 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. Subtract. So you end up with 0, and negative 4x squared minus negative 4x squared is 0. Carry this down. Okay, so now we kind of skip a term here, which is fine. So now you decide what times x gives you 2x. Okay, well, times 2. So 2 times x gives me 2x. Okay, when you subtract here, you get 0. Carry down the negative 4, and that ends up being your remainder because you're out of x's. You're done now. Okay, so you have this plus 2, which should not have happened. So what did we do here? Oh, I forgot to multiply it. Sorry. Okay, back up. I forgot to multiply times this negative 2. Okay, so multiply here to both of these. So I skipped it right there. So that should be negative 2 times negative 2. Okay, in which case you have this negative 4 here. So when you subtract, you get 0. So you'd have 2x minus 2x is 0, negative 4 minus negative 4 is 0. The reason that I know that that shouldn't happen is if it's an actual factor, if it's a solution, you shouldn't have a remainder, okay? So if you end up with a remainder, something happened, okay? So now what we have is we've factored this polynomial down to x minus 2 and then 2x squared plus 2. So if we want to find the imaginary solutions, okay, we already know this one gives us a solution of x equals 2. So now we just have to deal with this one to find the solution here. So you could do quadratic formula, okay, or since this one's only an x squared term, what I'm going to do is just set it equal to 0 and solve. So subtract 2 from both sides, divide by 2 to both sides, and then you can square root. Now remember, when you square root, you get a plus or a minus solution here. So plus or minus negative square root of negative 1. Remember that the square root of negative 1 is I. So those are your two imaginary solutions, I and negative I. So when we count up the total solutions now, here's one solution and here's two more solutions for a total of 3. Which is the degree of the polynomial, which is what we wanted. All right, last example. So this one's got an x to the 4th polynomial, or an x to the 4th. It's a degree 4. So let's take a look at these roots that we know. So we see that it crosses at negative 6. We see that it crosses at 1. So what we're going to do is divide those into this polynomial. Okay, now, you can do it how you want, but one thing I would maybe do is actually write those two factors out and multiply them together so that you only have to do long division once, okay? Just divide by both factors at the same time. So multiply this out and you get x squared minus 1x plus 6x minus 6. So you get x squared plus 5x minus 6. So I'm just going to divide that into this polynomial so that I only have to do it once. So I'm going to put that on the outside. And then this whole polynomial on the inside. Okay, and then I'm going to try and move this down. But then you only have to do long division once instead of having to do it multiple times for each factor. So what times x squared gives me x to the 4th? Well, that's x squared. So now I'm going to multiply this down to this whole polynomial. So x squared times x squared is x to the 4th. X squared times 5x is 5x cubed. X squared times negative 6 is negative 6x squared. Then you can subtract. So you will get 0. 11x cubed minus 5x cubed is 6x cubed. 34x squared minus negative 6x squared is plus 40x squared. And then bring down the 14x. Start over. So what times x squared gives you 6x cubed? So plus 6x. So multiply 6x times x squared is 6x cubed. X squared times 5x is plus 30x. 6x times negative 6 is minus 30x. Subtract these. So 6x cubed minus 6x cubed is 0. 40x squared minus, oops, that should say x squared. 40x squared minus 30x squared is 10x squared. 14x minus negative 30x is plus 44x. And then bring down the negative 60 to do your last one. So what times x squared gives me 10x squared? Well, 10. So multiply it and get 10x squared. 10 times 5x is 50x. Something's wrong again. This should have been 36. This should have been 6x times negative 6 to get 36 here. Because sorry, so this should be 50. because again, it's factors. So you shouldn't have any remainder. So when I did, it should have been 6x times negative 6 to get negative 36 here. And then when you subtracted, gotten 50. Okay, so then 10 times negative 6 gives me that negative 60 here, so that when I subtract, these are identical. So I get 0, 0, 0, so no remainder. Okay, so then you're left with this polynomial here. Okay, so what you've done is you've gotten the first two factors out of there, okay, which was x, what was it, x plus 6, x minus 1 is what you just divided in. And now we're left with x squared plus 6x plus 10. So this is the part that's producing the imaginary solutions. Okay, so to figure out, because this one gave me the negative 6, this one gave me the 1, so we need to deal with this. So then we can do the quadratic formula, because this is not factorable. So we'll do the opposite of b plus or minus the square root of b squared minus 4, the a is 1, so times a times c divided by 2a. And then simplify, so negative 6 plus or minus. So this right here, negative 4 times 10 is negative 40. So we have 36 minus 40 under the root. So we'll just get negative 4. And then divided by 2. Well, the square root of negative 4, so the square root of 4 is 2, so the square root of negative 4 is 2i. All of these divide by 2, so we'd get negative 3 plus or minus I for another set of roots. So we originally had negative 6 and 1 that we stole from the picture, and then we just found these other two imaginary roots to give us a total of 4.